Hello folks, we come to the part 4 video of the exercise 7.3 and let's see, we are taking up the 9th problem, and in this problem they are asking us to look at the word Monday and they are asking us to do different things in the different subparts. So in the very first subpart they are asking us to take 4 alphabets at a time and form different words. So we have to pick up the words from the we have to pick up the alphabets from the word Monday, and we have to form words with 4 alphabets. So as I said, always you should know how many choices are available, how many places to fill, then we are able to get the answers. So here, because it's a 6-letter word, we have got 6 choices, but we have to only fill 4 because we are forming 4-letter words. So in how many ways we can do it? We can do it in 6p4 ways. That is our first subpart. So we'll say that since 6 choices are available, and 4 places have to be filled. Therefore, number of ways of doing this is 6p4 by formula 6 factorial by 2 factorial n minus r factorial. And that way when we write it down, either that you write it and get the definition, or otherwise 6 factorial, if you know the value, I think that's more easier. 720 by 6 factorial is 720, 2 factorial is 2, so you can have 360 that way. Next problem is exactly identical. You have to use all the letters of the word Monday, but it's not, earlier we had 4 alphabet word, but now it will be 6 alphabet word. So like how we did the equation, you take all those alphabets, mix and match, make different words and find out how many such words you can make. So you are having a choice of 6 alphabets and you have to fill 6 places. So that's how it is. So it can be done in 6p6 ways, which is 6 factorial, and we know by heart it is 720. So in that way also we can write here 6 alphabets or choices are available and 6 places have to be filled. Therefore, number of ways of doing this. 6p6, which we have learned, that is 6 factorial, and that is coolly 720. That's all. In the next subpart, they say that you can form 6 alphabet word, but the starting alphabet should be a vowel. So there's a condition that's put there. So accordingly, let's see how we can work. So we have a 6 alphabet word. 1, 2, 3, 4, 5. This is fair enough, but here we have to have a vowel. Now in Monday, how many vowels are there? O is there and A is there. There are 2 vowels. So what happens is, this first place, it can be filled only 2 ways because there are 2 choices. So this can be filled in 2 ways. Having filled this first place, we are left with 5 places and 5 alphabets because already we have filled that one place. So that can be done in how many ways? 5p5 ways. So total way of doing this is 2 into 5p5. That's all. So let's check how you can do this. You can write that since the first place can be filled by only vowels. In a sense, it is O, A. So number of ways of doing this. It's 2. Okay, why is this Mississippi in between? We'll take it later. Right. Then we can say, having filled the first place, there are 5 choices and 5 places to fill. So therefore, number of ways of doing this. It is is 5p5, which we have already learned. It's 5 factorial and we know it 120. Right. So, therefore, total number of ways of doing this. If one work can be done in m ways and the other work can be done in n ways, and the total number of ways of doing the work is mn, so you have this 2 is there, one work, and the other work is 5 factorial. So it's 2 into 5 factorial. 5 factorial we have already learned, it's 120. So obviously the work number of ways in which you could have done this work is 240. That's how it's working up. Yes, it's coming to 240. Now the next question, that is your question number 10. That's how we had written the word there. Once again, let me write MI. Yes, this word Mississippi. The question says that you arrange these alphabets of these words Mississippi in such a way that I's are never together. You can make different combinations of this word where I's should never come together. Now, there are going to be questions where they ask such kind of thing. So, there is a strategy that you follow. What is the strategy that you will follow? First, we will find out the total number of words that can be formed out of these alphabets. First, we have to find that. Secondly, you will find out all those number of words where I will be always together. So, if you have these I's always together, then from the total, when you subtract the I's always together, you will get all the combinations where I will never be together. So, that's a strategy that we are going to follow. So, first we will find out now the total number of words that can be found from formed from these alphabets. Now, it's not so easy like the word equation or like the word Monday. We cannot form total number of words so easily. Why? Because there are repetitions. The alphabets are repeating. When the alphabets repeat, there's a slightly different strategy that we follow. So, that for the first time we are seeing here. So, we'll see that find the total number of words, then find out the words where I's are always together, subtract them, and that is going to give your answer. So, gradually let's do. So, here first let's write. There are 1, 2, 3, 4. 4 I's. Then what else? 4 S's. 4 P's. That's it. 4 plus 4, 8. No, P's are 2. 4 plus 4, 8, 9, 10, and 1 M is there. That's how we have the 11 alphabets. So, Mississippi is a word which is formed out of 11 alphabets. Whenever there are repetition, this repeated number of factorial has to be divided to get the total number of words. So, let's write. Therefore, the total number of words that can be formed out of these alphabets, Generally, we used to take 11 factorial directly. Here also 11 factorial because there are 11 alphabets, but repetitions. Whenever there is a repetitions, you have to take care of repetitions, and then only you will get proper words. Otherwise, there will be lots of repetitions and mismatch, and then you don't get distinct words like that. So many words will be there that can be formed out of these alphabets. Now, as I said, our next step is to take all the I's together. Now, how can we get the I's together? For that also you use a different strategy. What we do is we stick all the I's together and we form it as a single capsule. We call it as a unit. Okay, so it will be an I unit. So what will happen is our word will collapse and the word will now have 4 S's, 1 M, 2 P and the I unit. In that I unit, of course, the 4 I's have we have stuck it together and we have made it a single thing. That will allow us to give the combinations where the number of words where the I's are always together. If you get the number of words where I's are together, if you subtract these two, you will get all those words where I's are never together. That's a strategy that we follow to find out such problems. So, that we have to mention. Now, we fuse the I's together to form a single unit. So, our resulting word has 4S, 2P 1M, and the I unit. So basically when you look at it as alphabets, there are 8 alphabets. So number of ways of forming this word, number of ways of forming this word where I's are always together is 8 factorial. Of course you have to account for the repeats, so that is 4 factorial and 2 factorial. Wherever you go, you have to account for the repeats. So that is why, because P's and 2 S's are there, so you have accounted, and these many are the number of words where I's are going to be together. Now they ask us, therefore, number of words where I's are not together, number of words where I's are not together. We are going to subtract them. Total minus the places where I is together. 11 factorial, 4 factorial, 4 factorial, 2 factorial, minus 8 factorial, 4 factorial, 2 factorial. Now I can use all your factorial logic and try to get it simplified. 8 factorial we all know is 11 factorial is 8 factorial into 9 into 10 into 11. And then we can have it pulled out. 8 factorial can go out, 4 can go out, 2 can go out, and here we are left with 9 into 10 into 11, and these two have gone out, only the 4 factorial is left here. Here nothing is there, everything has been pulled out. So this is what is remaining. I wonder if we can have this 2 into 3 into 4, if we could have anything that is possible. Yeah, 2 5s and 3 3s. What are we left with? 8 factorial by 4 factorial into 2 factorial, and this is now 5 3s are 15 and 15 into 11. 11 5s are 55, 5 carry 11, 5s are 11, 1s are 11, 16. So it's like 165 by, so what we get here, 165 by 4 minus 1. Now this has to be simplified into 4 into 4. So it's like 8 factorial by 4 factorial into 2 factorial into 165 minus 4, 161 whole by 4. Okay, if you could use our permutation logic here, 4 factorial into 5 into 6 into 7 into 8. And then we have this 4 factorial which is going to cut 2. We can be writing it like this, and then this 4 is also there. So this is getting cut. 4 2s are 8 is getting cut. So you have 6 7s are 42 and 161. Let's have that. Or you could have 6 5s are 30, and then 161 into 7, 42, 11, and the 30 ka 3 is there. 7 3s are 21, 3 2s are 6 and 1 7, 3 3, 3 3, 3 2s are 6, 7 2, oh 21, okay, 3 3 8 1 0 are the number of words where I's will never be together in the word Mississippi. That is our problem number 10. With the next problem, we meet in the next video. Thank you.